In this video, we are going to solve a system of three linear equations using the Cramer's rule. Consider this system. Here we have three equations and three unknowns, that is x, y and z. So our goal is to find the values of x, y and z that satisfy all the three equations. But before we start calculating, there is one important question. Can Cramer's rule be applied to this system? Let's find out step by step. The first thing we need is the determinant of the coefficient matrix. So step 1 is to find the main determinant, which is denoted by the letter D. We take only the coefficients of x, y and z. So the coefficient matrix will be 2 1 1, 1 minus 1 2, and the last row will be 3 1 minus 1. Now we calculate its determinant. So here we will get D is equal to 9. Now this value is actually very important since here D is not equal to 0. Therefore this system will have a unique solution, but still we need to find actually what are the solutions. Means I'm going to say or going to explain you that actually what are the values of x, y and z. So now let's move towards finding the values of x, y and z. Now first step, for that thing we will be firstly finding out what is dx. What exactly is dx? For dx we take the original coefficient determinant and replace only the x column with the coefficients from the right hand side of our equations. Now notice carefully, only the x column is replaced. The y column and the z column will remain exactly the same. So our first auxiliary determinant will be dx, and same procedure we will follow to calculate dx as well. So now dx is what? Dx is equal to 6. Now moving further, we will be calculating now dy. Now this time we will replace the y column actually. Y column with the constants which are towards the right hand side of the equations, that is 6, 3 and 2. Now notice the difference from dx. Here we have replaced the second column, but in dx we have replaced the first column. Dx first column are all the coefficients of x variable. Second column are all the coefficients of y variable in all the given three equations. So in this dy we do not change the first or the third column. After calculating dy by solving the same, by using the same process, we will be having the value of dy as 2. Now the final step will be to calculate or to find the value of dz. For dz we will replace the z column with the constants. Means we will keep the same process which we have used earlier, that now I will not be changing or disturbing x and y coefficient column. Means I will not disturb first and second column, I will be only changing the third column. Now after this, the third auxiliary determinant, that is dz, will be 21 now. Now after this, now we have everything which we need to actually calculate the values of all x, y and z. Now Cramer's rule tells us that when d is actually not equal to 0, the variables are obtained by dividing each corresponding auxiliary determinant by the main determinant. Like for example, for x we use dx divided by d. For y we will be using dy divided by d, and for z we will be using dz divided by d. So we have found all the three unknowns now. Therefore the solution of our system will be dx divided by d means x, that is 2 by 3. Similarly for y I will be having 7 by 3 value, and for z also the value will be 7 by 3. So the system has this unique solution. Now let's have a final recap. So what we do for a Cramer's rule, the complete Cramer's rule process is actually to firstly find d, then replace x, y and z columns step by step, one at a time, to find dx, dy and dz. And finally we will find the variables, that is x, y and z. That's it. This is the Cramer's rule for a unique solution. Now before moving to the next case, remember the key condition which was here is that d is actually non-zero. Now what happens if d is equal to 0? Can the system still have a solution? It will have. So we will find this in our next upcoming videos.